And welcome back to a teardown video of a UK domestic power meter. This is a UK single phase domestic power meter. This was a what they would call economy 7. It has a low and a normal, so that's like day rate and night rate, and a little thing that pulses, and if you count them you get 800 pulses per kilowatt hour. Not quite sure if you can read it down there, it's a bit, it has been up on the wall since 1988, it says down there. I got the serial numbers covered up because these things are meant to be taken away, but it got left behind, and so best not to identify myself too much, because obviously they can track it back to me with a serial number. Oh, we've got a little you can see it in there. Oh, there we go. 1 and 2 is the main, 3 and 4 is the load, and 7 is a switched neutral. So maybe that's the bit that denotes when it changes from high to low. You can see here, there's the high coming in, big solid lump of copper for the neutral coming out, there's the high coming out, and there's that little low. Right, how do we get in any further? As you can see, it has seals on it. So my trusty rusty cutters, which say on there for music wire. I think somewhere there's I thought it had an army stamp on it somewhere, a little military thing. But these make short work Am I trying to cut through 2 at once now? Short work of anything that's heavy, heavy gauge. Right, so what happens now? I can that doesn't seem to do much, can't seem to turn that. What's that do? That takes off the hanging bracket. Ooh, that don't turn. There's a screw. Down there. Oh, they fell out. Just that comes out. Ah, I see it. You pull them out, and now you can undo them. Ugh, a dead spider on that one. Is it either a dead spider or it's it's one that has decided to oh, right, I'm going to take this off camera now. Just going to pause. Right, that releases the case. And I've splatted out some more information. And it's how do we get any further in? Screw there, and some screws down there. Does this lift off? That seems to be attached to the board. No, that's too big. Try one of my Parkway. Is it Parkway? I don't know. Lidl. It sticks in those. No. That's coming off as well. They all come. Oh, it's all coming loose, apart from this bit. Ah. That's how you do it. Well, they don't do that in there. What's that bit for? Ah! Ah! What can we do with them another day? I was expecting to see some sort of rotating wheel that you used to see. Oh well, there's another screw here. Take all the screws out, why not? Oh, obviously a seal of some sort. Not a lot to look at, but we'll come back on that and have a look in depth later. So what's left in here? We have some metal plates, whether they're to give it some form of screening. That is some really chunky magnet, doesn't stick to it. So that's some chunky brass. Oh. Solid bit of plastic. And the sealing ring. Another bit of plastic. That looks like glass. So I might take that out. Might be able to laser that, make something pretty with it. whereas this lot goes in the plastic bin and the metal can go in the metal bin. That's a mess it's made. These are really dinky. So 2 of them. I don't know how easy it is to... Right, look at that. It goes backwards just as well. That's great. I can think of a use for them. Just as silly little dials. Put a servo on them or something. Put a servo on them for a bit of a laugh. So that can go in there. The seals. They can go in the bin, or they can go in the metal pile. And I'm going to stop while I get this black. Alright, back to here. And I think the interesting bit is what's going on here. So, where are my cutters? So let's just go. I'm not going to ever use it again, so chomp through there. What's on here? Well, the plastic seems to come off. Bit more plastic. Is that soldered on? Seems to be soldered on. So that looks like one hell of a current shunt, as it seems to be measuring the voltage across those 2 bits. Why it's got that little nick, little saw cut in there, but and why it needs that extra one, I don't know. But that is obviously, whoops, it's gone out of focus again. Obviously one high powered current shunt. So it's high power by the size of the holes and the size of these big screws. Right, so not much information gained from there. I'll just delete the bit where you can't see it. Right, what we got then? We have a K275 suppressor. It's obviously reasonably modern because it's surface mount. And 2 stepper motors. I have to desolder them to a closer look. They do look remarkably like some form of stepper motor. That's the LED for the high and low economy 7 night and day indication. There should be one somewhere else. Oh yeah, there it is. The one that flashes when... That's the one that flashes 800 times per kilowatt hour. That looks to be like some very accurate thick film resistor array. And we got, I can't remember which one of these was on the... oh, that was the neutral, that was the switch. So that's obviously the bit that lets it know when it's hot, night or day, and that come from a unit that I'll tear down in another video. Looks like it was on the possibly the 25th week of 88. The numbers tie up with all the other numbers, and there's no way I'm going to do a big Clive and say, oh look, I've got it down to exactly what it is. Are they Nichicon capacitors? So obviously they expect this to last. And what are the chips? Well, that one's got a crystal on it, so that must be a microprocessor. Problem is, you ain't got a clue what they're going to do because they're custom. The same as that one. So, keeps wanting to focus on them, I suppose. Yeah, but you're not going to gain much information from that. So, that's the insides. Nothing spectacular. Looks like a capacitor dropper and some weird form of stepper motor that only seems to go a step at a time, because you push it and it flicks 180 degrees. That's all it does. So interesting. Not quite sure what that is. Is it another? It can't be a current shunt. It's sat on top of that ground plane. Well, I thought this would be a bit more exciting, but it's not. It's all specific ICs, custom resistors. Because obviously these are made to a standard, and they must meet the standard for all the years that they're running, because that's how they know how much energy your house has used. So I might take these off, have a play with them, as I can't think of anything else being of use. These Nichicon cameras are Nichicon capacitors have seen serious running hours, so I might take them off. They might be useful, but not many salvageable parts. Well, I stripped down a little solenoid motor off of the PCB. As you can see, there's a single coil in there with a metal pole piece and this little cog or arm. It's got a pin and a socket, pin and a slot, and we look on there, it's got a pin and a slot, so they mate. It's a 500 ohm coil. You need a H bridge to drive it, because if you keep doing that, it just rocks backwards and forwards. But if you swap the polarity, it shifts 180 degrees. Swap the polarity again, and it shifts, and it's only going in one direction. So there must be a little H bridge on this PCB. So it's obviously built into one of the ICs, as there's not enough transistors on there to form an external H bridge. So, and then the other interesting thing, bringing the little camera in, each time this little wheel turns 180 degrees, I'll get this way up, you see that 2, 1, 0, 9. Each time it turns 180 degrees, the cog changes one digit. But you can't move. You can spin this one freely, and you can see that little hole there, little slot. It's a very good focus. That little slot there. When you go around to the other side, you'll see there's a paddle. And what happens is when that slot comes round, it catches a little paddle and it turns and drives the next cog by 1. So for each one of, let's just move that out of the way again, bigger. So for each 180 degrees you get a count of 1, and then for every 10 it moves over. But because that little flap has to go into that slot, effectively it's a one-tooth cog. So it comes round and it falls into that, and it allows it to rotate. But if you try and move it any other time, none of these can rotate, because if you bring it round again, for a cog to rotate, this extra piece that you see there has to go in. It has to physically go into that void that that cog has on it, and so there isn't enough room for the little white cog to rotate until the void comes past, and then it can dip into the void and see that it sticks at the next one. Notice first paddle goes in, rotates it, and then the next paddle stops and it stays pushed against that edge until it comes past again, and then it falls in. Very clever. So my plan now is to mount these somehow, make a little H-bridge driver, rewind it back to 0. I'm going to have a mechanical subs counter. I hope you found that interesting. Well, if you found that interesting, I thought I'd show you a close-up of the little precision resistor board. And as you can see, there are various laser cuts. Here's the edge connector where it was mounted to the board. But there it is again in close-up detail. But when we focus, we'll get to focus on the actual resistor tracks. You'll see the laser burns into the substrate where they're altering the value. So these are precision resistors. They will be put into the meter, and I expect the meter will be tested, and then depending on the error, the laser will fire dots and slices into the resistors to trim their values, as of course you're being charged for what these meters say you've used, so they have to be accurate, and this is how they make them accurate. Well, I hope you found that interesting, and if you did, hit the like button, subscribe, and catch you on the next one.